Yeah.
Yes.
Good afternoon once again, and I'll request someone to lead us in a word of prayer. Yes, Valeria, sorry. You can unmute and share with us. Valeria, you can please unmute and pray for us.
Okay, let's humble ourselves and we pray. Our kind and precious loving Father, we pray for this lesson, Lord, that it may be successful. We understand what the teacher is going to tell us. In the mighty name of Jesus Christ, amen.
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 Thank you, Valeria.
You're welcome.
Okay, so I hope I'm with senior threes. And
Yes.
okay, all welcome and congratulations upon the new year and the new class that you're in.
Thank
Yes, so I'm going to be taking you through, and I'm Teacher Martha. I will be taking you through chemistry. And our first lesson today will really base on our first topic in senior 3. Who has a clue on what that topic is? You can share your answers in the chat, or you can raise your hand and tell us what you think our first topic is in senior 3. Anyone who has an idea? Okay. Tekino, come on, is saying carbon. Thank you. That is a good idea. Anyone else?
Carbon.
Carbon, okay. Someone is saying chemical bonding, someone else is saying organic chemistry, okay. These are all good thoughts. Okay, so when I talk about soap, when I talk about detergents, when I talk about crude oil, what comes to your mind? What do you think we are going to look at if we mention such kind of things? What components do you think we are actually looking at when we talk about petrol, paraffin, a candle, soap, detergents, oil? What comes to your mind? Which element do you think we are basically going to focus on in this chapter? Okay, someone is saying carbon, another one fuels, another one carbon. Okay, these are beautiful answers. So basically, we are going to be, you realize that all those things I've mentioned, we use them in our daily lives. Someone is saying carbon in the environment. Okay. So we use them in our daily life. So basically, we are going to be interacting with carbon in life. So our topic this afternoon will focus on carbon in life. How can we interact with carbon in our daily lives, and how do we experience it? Because you realize that everything we see or touch or have or relate with is made up of carbon. So at least you find that even in your body, there are those things that are made up of carbon. Even in the things you relate with, the food you eat, the utensils, everything at least has a component of carbon in it. So that is why we are going to look at carbon in life. Okay, so we have some keywords in this topic, and I want someone to unmute and read for us each keyword I will be highlighting. And of course, we'll keep interacting with them. I'm not going to ask for their definitions, but We'll keep explaining them as we get there. Van Bragatash, I don't know if that's the right pronunciation. You can read for us the first 4 words, and then we can have someone else.
Anaerobic.
Mm-hmm.
Alcohol.
Mm-hmm.
Detergent.
Mm-hmm.
Fermentation.
Okay, very good. So let's have Agatha read for us the next 4 words.
Functional group,
Mm-hmm.
hydrocarbon,
Mm-hmm.
homologous series, natural gas.
Okay, very good. Thank you. Can we have someone else read for us the remaining words? Yes, Patricia.
Polymers, soapy detergents, soapless detergents, soft water.
Okay.
Suspension,
Okay, and then we have alkane. So those are some of the words we'll be interacting with in this chapter. And I want us to take conversant of them. Oh, someone is telling. Okay, thank you. I'll make that correction on that. Yeah. Okay, so we also have of course we know that we have learning objectives that we need to have at the back of our minds in this topic. But of course, there are several. If you can be able to access them, the better. But I was able to come up with only one, but there are very many. There are about 11 learning outcomes. So that means at the end of this topic, we must be able to have attained at least most of those learning outcomes. So may I have Linak to read for us this learning outcome? Linak, your hand is up. Can you unmute and read for us the learning outcome? Okay, can we have someone else who can unmute and they share with us?
Me.
excuse me, madam.
Yes, please.
Your words are a bit small.
Is it that we are not able to see them?
Not that clear.
Okay, I'll try to make them bigger on the next slide. Okay, let's have Bridget.
By the end of the chapter, you should be able to recognize that there is diversity of carbon compounds, living things, and materials derived from living things, and this may be classified into groups.
Okay, thank you. So we recognize that there is diversity of carbon compounds in living things and materials derived from living things, and these may be classified into groups. Like we are going to see the different groups in which those different compounds belong. Okay, so those are the keywords that we had to look at. And the learning objective is that just briefly.
Joy, stop writing on teacher's screen.
Sorry.
Okay, so are we all able to see my screen?
Yes.
Yes.
Okay, so may I have someone to read for us the competence? And I hope the letters are now more visible for every one of us. Patricia?
Competence. The learner will appreciate the diversity of organic carbon compounds, including the alkanes, alcohols, and fatty acids.
Okay, thank you. So in this topic, as a learner, you should be able to appreciate the diversity of organic carbon compounds, including what we call the alkanes, and of course, we'll know what those ones are, the alcohols, and then the fatty acids. So all these are important elements in our lives. They're important compounds in our lives. So we need to know how to go about them, especially this topic. So as we go through this topic, you should put emphasis on those, as well as the rest that we'll be looking at. So, of course, we know that carbon is one of the elements found in a periodic table, and I know all of us looked at periodic table in our senior too. So you should be able to relate. So what is the position of carbon in the periodic table? You can put your answer in the chat, or you can raise your hand and unmute and tell us. Sekino? Okay, Amara, let's have Amara. You can
I would
unmute.
say it's the sixth.
Sorry?
I would say it's the sixth carbon.
I am not hearing you.
Teacher, I'm saying it would be the sixth. Teacher, have you heard me?
It is the what?
The sixth.
Okay, that's an element. Thank you. Yes, Miranda.
I think it's in group 4.
Okay, very good. Let's hear from Tekino BF7. Please, if you're putting up your hand, make sure when we call your name, you unmute. If you're not able, then put your hand down. Okay, Linik, sorry.
6.
Okay, so we realize that carbon is the sixth element in the periodic table, and it's in group 4 and in period 2. So it's important to know the position of that compound. So it's in the second period, the 4th group, and of course, it's the sixth element. Okay, so in what substances can we find carbon in our environment or in our daily lives? What are some of those things we work with that contain carbon in them? Yes, Wandera.
In charcoal.
In charcoal, very good. Joyce.
In wood.
In wood, very good. Miranda.
In charcoal.
In charcoal, good. So we have someone saying hair, coal. These are all beautiful answers. Firewood. And I'm seeing food, charcoal. Even your human body contains some things. Okay, Felista.
Teacher, what about in dry cells?
In dry cells, good. Then Joyce.
Suit.
Sorry?
Suit.
Good, okay, good. Wandera. Patricia.
In dust, madam.
Trees.
In trees, in dust. Okay. Living things, diamond, graphite. Okay, those are all good. So let's continue. I hope my letters are now more visible. Are they? Oh, they are still very small.
Yes, they are.
Mhm.
They are medium.
Oh, okay. At least that's better. Thank you. Okay, so can I have someone read for us this question and then give us the answer to the question? Yes, CM.
The question is, why does maize or meat turn black when burnt?
Anyone with an idea? Yes, Sarah.
They contain carbon.
Okay, very good. Yes, they contain carbon. And I think Dora had also given us the suggestion in the chat. So you realize that the charcoal that is burning them contains carbon, even the maize and the meat itself contains carbon. So when those two are burnt, they produce carbon dioxide and black carbon, which actually causes them to turn black. Okay, so that is what I wrote here. Maize or meat contain carbon, which burns to form carbon dioxide, and burnt carbon, which is black. And of course, you can see in these images at least a feel of what actually happened. So you realize that the maize here is turning blackish, and this meat here as well, because they both contain carbon, and when that carbon burns, produces carbon dioxide and then carbon. Okay, so of course we know that carbon is categorized into two groups. Who has an idea on which those groups are? Anyone with an idea on those two groups in which carbon compounds are termed as? Of course, we looked at one of the groups when we were looking at carbon in the environment in senior 2, and then the other one is the one we are going to interact with in today's lesson. So who remembers the one we did in carbon in the environment? Which part of carbon did we cover? Yes, Rahi? Okay, someone mentioned alkane. Alkane is in one of the categories that we want to look at, but thank you for that suggestion. Linek?
Amorphous and
Okay, amorphous also falls in one of those categories. Good.
Madam, can I try? Hydrocarbons.
Hydrocarbons, okay, good trial. Nakanyike?
Carbon compounds are grouped into two.
Please, if you're not chosen, kindly keep your mic muted because it keeps sending feedback that isn't very polite for the ears. Okay, so
Madam,
those two. Yes, please.
Trial. Entropy.
Okay, so when we are looking at these, we have
Madam,
the organic compounds and then the inorganic compounds. Please, if you have a question, raise your hand, or if you have an answer, raise your hand. Because if you keep calling madam, it may not really be healthy for all of us. So let's just keep the discipline of raising your hand and you say something, or you post in the chat at least 1 or 2 times. I'll keep checking in the chat to look for what is there. Yes, Kenneth. Okay, so these are the two groups. We have the organic compounds and then we also have the inorganic compounds. So the inorganic compounds I've been talking about were the ones we looked at in the carbon in the environment, where you looked at carbon dioxide, carbon monoxide, all those other components of what? Of carbon that you looked at there. So these inorganic compounds are the ones where you are looking at those different compounds of carbon. But today in this lesson, we'll be interacting with what we call organic compounds. And who can tell us what they think about organic compounds? What comes to your mind when you hear the word organic compounds? Yes, Alinda. Alinda, are you saying something? Because I can't hear you. Okay, someone is saying natural compounds. Good trial. Patricia, you can unmute and tell us.
I think organic compounds are those that decompose.
Those that decompose. Good trial. Tekino. Okay, so here when we are looking at organic compounds, we are really going to interact with carbon, bonding with other elements other than those elements it bonds with in what? In inorganic compounds. So as we go about the topic, you really understand what organic compounds are in depth. Okay, so who can tell us what the difference between organic compounds and inorganic compounds? Who can try? Okay, so here, like we'll see, when you're looking at organic compounds, we are basically looking at how carbon combines with hydrogen and any other compounds, but hydrogen has to be part of those what? Of those elements that it combines with. But when you look at the inorganic compounds are a bit distant. For them, you will have carbon bond with other elements without the involvement of hydrogen. So you can find carbon sulfide, you can find carbon dioxide, you can find carbon monoxide. But when you look at the organic bit of it, you'll find what we call methane, Am I breaking for everyone or for a specific person?
No.
Specific person.
We can hear you
Okay.
well.
Thank you. So that is book, or someone is asking if it's book 2 or book 3. It's book 3 because you're now in senior 3. So we are looking at book 3. Okay, so any examples of organic and inorganic compounds? Let's start with organic compounds. You can post in the chat what things you think are made up of organic compounds in our daily life, and which things you think are made up of inorganic compounds. And remember, we are trying out, so it is not bad to mention your answer, and we get corrected along the way, and you never know your answer is actually correct. So let's have some examples of organic compounds that we know. In the chat, someone is saying fertilizer, very good. Ethanol, good. Any others? Methanol, good. Charcoal, very good. Coal, sucrose, oh, these are very good answers. Decaying matter, wax, cellulose, these are all very good answers. Plastics, good. Paper, very good. Skeleton, very good. Okay, so all these are beautiful answers of organic compounds. Meat, okay, good. So we also have inorganic compounds. Can we give some examples of inorganic compounds as well? Any answers of organic compounds? Carbon monoxide, very good. Minerals, which minerals? Be specific. Water, good. And of course, we also have the diamond, graphite, all those components of carbon that you looked at in the what? In carbon in the environment, all fall under inorganic compounds. Okay, so thank you for your suggestions, but then it would be more beautiful if some people would raise their hands and air out their answers other than posting in the chat. Okay, so we have some examples here that the picture's resolution may not be as clear, but at least I want us to pick a leaf as I read out some of the examples. So we have paper, and paper contains cellulose, which is an organic compound. Of course, I know you looked at that in using materials where I looked at cellulose. And then nail polish, which has nitrocellulose and butyl acetate. Then we also have candle, which contains wax and tallow. Then we also have fabric, which contains cellulose, nylon, and rayon. Then we have soap, which contains fatty acid salt. Then we have gasoline, which contains mixed hydrocarbons. So these are some of the examples that I told us that they are within our daily lives. Then we also have DNA, because every one of us, at least if you're a living person,
Madam, you're
you have.
you're still writing.
Sorry?
You're
I'm
too fast. Yes.
Oh, sorry.
I'm still writing. I'm on candle.
Okay, sorry. And then someone is asking us to revisit organic and inorganic compounds definition. As we go about, we will see the basic definitions. But like I said, when you're looking at organic compounds, you're looking at the combination of carbon and hydrogen with any other what? Elements. So carbon and hydrogen are a main component when you're looking at organic compounds. Then when you come to inorganic compounds, you're looking at carbon combining with other elements such as oxygen, sulfur. Of course, for it doesn't need hydrogen to exist for it to be an inorganic compound. So that means in inorganic compounds, you'll have elements like carbon dioxide, carbon monoxide. So you notice that I am not mentioning hydrogen anywhere, carbon sulfide. But when it comes to organic compounds, like we are going to see the examples, you'll appreciate the definition better when we see the examples of those organic compounds. You realize that hydrogen is an important element with carbon when you're looking at organic compounds. Those who are saying I'm fast, I'm very sorry, and thanks for the feedback. So Agatha, have I tried to help when it comes to the definition of organic and inorganic compounds? Okay, thank you. So I was still saying when we have examples of organic compounds, we have paper, which contains cellulose. And of course, which contains nitrocellulose, butyl acetate. Then we have candle wax, which contains
Pardon, about paper.
paper contains cellulose. And we all know paper is extracted from wood, and wood has the biggest percentage of what? Of cellulose. Dora, that may be hard for me to type in the chat, yet I am teaching. So just listen in and be able. And the recording will be posted on our group, so you can go back and rewatch so that you can get those definitions over and over again. But if I say I am typing in the chat, I may end up typing everything. Eh? So you go back to the recording and you're able to get some of those. I hope that is okay. And then we have fabric, we have soap, and then we have gasoline. Oh, there are groups where they post these recordings after. So please, if you're not in that WhatsApp group, I'll request someone to copy the link and share with the rest of us so that we can join those groups, because that's where the updates are posted and everything really. And then of course we have some other examples here. We have the DNA, we have perfumes, we have soap, we have nail polish, we have candle, and then we have paint. So in the organic compounds, we have DNA, perfume, soap, nail polish, candle, and then paint. And then for the inorganic compounds, we have sodium chloride, we have diamond, we have water, we have calcium carbonate, we have hydrochloric acid, we have carbon dioxide gas. Someone is asking what is gasoline. When we get to crude oil, we'll look at the details of what gasoline is. So let's just be patient till we get there. But at least the diagram can communicate to you what gasoline is really. So we have, those are the inorganic compounds that we can actually relate with. Are there people who are still writing, or I can scroll to the next slide?
Yeah, we are still writing.
Okay, let's try to be fast at that.
Let's continue.
Okay, thank you.
Madam, finished. Finished.
Thank you for that feedback. So we have the classification of organic compounds. So when we are classifying, yes, this is the first topic in senior 3. So when we are classifying, the same way we have different tribes in Uganda having different names. So such that when I say Akelo, Opio, Odeke, you realize that those names fall in a certain tribe in Uganda. Then maybe when I say Namuli, Namatovu, Namayanja, Mayanja, Sempuma, any other name, you also categorize that those names fall under a given tribe. Then I can say Ahewa, Ampurire, Ampaire, Ayebasiwe, Tusime, Talemwa. You realize that also those ones fall under a given tribe in Uganda. So it is about, when we are classifying these organic compounds, we also look at what names do these compounds carry, and then we are able to put them in a certain group. So it is really about when we hear your name, and then we are able to tell which tribe you actually belong to. Okay, I can see some people are posting some names. I hope those are your names that you are posting. So all those different names fall under those different tribes. So it's the same thing with organic compounds. When we are putting them in a certain category, they must have that relationship that identifies them to be in that given family. For example, maybe they are talking about the Chiwanuka family, the Chagulanyi family, the President Museveni's family. So you realize that they fall there because they have something that connects them to fall in that what? In that family. So you realize that we come up with a specific grouping on those names. So it's the same thing we are going to do with these organic compounds. So of course, same case in organic compounds, the name helps us to know the family, a given compound belongs to, and these families are what we call the homologous series. If someone can remember, we looked at this in the keywords that we'll be interacting with in this topic. So homologous series are those families where those different components belong. So when you have a family where those different elements belong, but they have a general formula in this case, because remember we are looking at compounds. They have a general formula and they have general chemical properties that qualify them to fall there. Like for example, if they are to say maybe you belong to the royal family, there are criteria you should be having that qualify you to belong to that specific family. So it is the same thing with homologous series. They have a general formula, and then they also have similar chemical properties. I want us to take note of that. The reason why I'm over repeating it is because I don't want people to keep asking for the definition of what a homologous series is. So you find that these compounds have the same general formula and they have similar chemical properties, as we are going to see. So we are going to look at very many chemical properties. Please, let's keep the chat focused on what we are studying so that if I keep checking, it is for academic value. Thank you. So we have someone read for us this definition. You can raise your hand and then you read it for us. Okay, let's hear from Amara.
Homologous series. The homologous series is a family of organic compounds with similar chemical properties and have the same general formula.
Okay, very good. Thank you. So when you're looking at homologous series, it's a family of organic compounds with similar chemical properties and same general formula. Like we are going to look at some of those homologous series this afternoon. Okay, so naming here depends on the number of carbon atoms in a given compound. So as we will see when we go into those different homologous series, that the number of carbon compounds in a of carbon atoms in a given compound determine the what? The name. Van, can I, let me just shorten your name because your name is quite long. Your hand was up. Lenik?
Yes, please.
Your hand is up. You have something to say?
No, just wanted to read.
Oh, okay. So, what are some of the examples of homologous series that we can look at after understanding that it's a family of organic compounds? Who can tell us some of the homologous series they think exist? Yes, Miranda?
Ethanol.
Ethanol falls under a specific homologous series. Which homologous series is that? Because ethanol is an example of one of the homologous series we are meant to look at. Someone is saying acids. Oh no, Trilly. Thank you, Dorado. Then Megan is saying alkanes. Very good. So alkanes. Ethane is an example that falls in a particular homologous series. So which homologous series is that, Emily?
Madam,
Megan
I
has
have
told us alkanes. Okay. Go ahead.
hydrocarbon.
Alkynes. Hydrocarbon is a general term. Don't thank you for that trial. Okay, I'm seeing some answers coming through. Alkanes, alkynes, arenes, alkenes. Okay, all those are beautiful answers. So down here, we'll look at some of the examples. Of course, as we are looking at those homologous series, also something has to come at the back of our mind. The homologous series we have, I'll just let me share a whiteboard and I just outline some of those reactivity series, those homologous series, but of course we'll see most of them as we go about the topic. We have the alkanes. We have the alkenes. And we'll look at every one of these as we go about this topic. So you don't need to worry yourself on what they mean. Then we have alcohols, where someone mentioned ethanol. So ethanol falls under the homologous series called alcohols. Then we also have carboxylic acids. Please don't be scared. These are all easy things that we'll get to know as we go about that topic. So those are some of the things we'll keep interacting with, and you should have them at the back of your mind. Alkanes, alkenes, alkynes, alcohols, and then carboxylic acids. Okay, so I'll go back to what we're looking at. So we look at the functional group. Of course, we are going to interact with these functional groups as we look at the homologous series. May I have someone to raise their hand and they read for us the definition of what a functional group is? Yes, Akram?
A functional group is an atom or group of atoms responsible for the characteristic chemical reactions of particular compounds of the same homologous series.
Okay, thank you. Hannah, do you have something to say? Okay, so when you're looking at homologous series, so you can't eliminate the functional group. So when you're looking at a functional group, this is an atom or group of atoms. And like we'll be going about these different things. I'll keep referring you back and I tell you, this is its functional group. This is a homologous series called this. So I just want us to have these definitions so that when I mention them, we don't seem like we've not heard of those things. So a functional group is a group, is an atom or a group of atoms responsible for the characteristic chemical reactions. Because remember, we've said in homologous series, these compounds have the same chemical properties. So it brings about that similarity in what? In chemical reactions of a particular compound in the same homologous series. So those are some of the things you need to move with as we go about this topic. And then like we said up there, we said that we mentioned something here that naming depends. When you look at this statement, naming depends on the number of
carbon
here.
atoms.
Naming depends on the number of carbon atoms. So when you look at this statement, that is what I am going to highlight down there. Naming depends on the number of carbon atoms. So on our next slide, that is what you're going to take note of. When we have, I hope I'm no longer as fast as people said I was initially. I hope at least my speed is now okay.
Yeah.
Okay, thank you.
Yeah.
Yeah.
So when we are looking at this homologous series, we name according to the number of carbon atoms. So if we have one carbon atom, which is one carbon like that, we call that compound a meth. So depending on which group it falls in, we add the other name, but the suffix, the prefix, sorry, is the what? Is a meth because of that one carbon atom that exists. Then when we go to the one that has two carbon atoms, its prefix is an eth. So that means when we are looking at alkanes, we'll call that ethane. When we are looking at alkenes, we'll call that ethene. When we are looking at alkynes, we'll call that ethyne. So this one will have two carbon atoms, and that is why we'll call it eth. So it's important to know those prefixes. And then when we go to the one that has three carbon atoms, the one that has three carbon atoms is what we call the prop. So when we go to the different homologous series, we'll appreciate the naming. But you need to know that if a carbon compound has three carbon atoms in it, it has a prefix of prop. Then when we go to the one with four carbon atoms, it becomes what? Bute. So that means if it has four carbon atoms, it becomes a what? A bute. Depending on what homologous series it falls in for us to add the suffix. And then when we go to pent, you realize that this one has 5 carbon atoms. Those 5 carbon atoms represent the pent. So when we get to 5 carbon atoms to around 10 or even below, you realize that those names become polygonal names. For example, a 5-sided figure is called a what? Someone to quickly say the answer.
Pentagon.
Yes, it's called a pentagon. So in the word pentagon, we go and remove the first 4 letters, which are pent. And that is why we say that the carbon compound with 5 carbon atoms is what we call a what? A pent. And then when we go to a 6-sided figure, who can quickly tell us what a 6-sided figure is called?
Hexagon.
Hexagon. Very good. So if we have a hexagon, that means if a compound has 6 carbon atoms, it's called a hex. So we cut off the other argon and then we call it a hex, depending on what homologous series it falls in. Then someone to tell us a 6-sided figure, what is its name?
Heptagon.
Heptagon, very good. Or some people call it a septagon. So it's the same thing here. We cut off the hept and call that those compounds with 7 carbon atoms are called hept. So we remove the argon and then we keep the HEPT, or we keep the sept because it's called a septagon in some instances. So we keep the sept and leave the argon. Then the 8-sided figure, what is its name?
Octagon.
Octagon. Beautiful. So we have octagon as the 8-sided figure. So that means a compound with 8 sides. Who can tell us the prefix we'll choose? Oct. Very good. Wow, that's very nice. So we cut off the what? The oct. Then a 9-sided figure, what is its name?
Nonagon.
Very good, nonagon. So what do we call, what prefix do we choose for a 9 carbon compound?
None.
None. Very good. So we carry the what? The none.
None.
Very good. And then a 10-sided figure?
Decagon.
Decagon. Very good. So what do we cut off to get the prefix for 10? Deck. Very good. And then we leave out the argon. Okay, that's brilliant. You people are very sharp. That's nice. Okay, so I don't know whose mic is unmuted. I'm getting my feedback.
Some of you please mute.
Okay, thank you. Okay, so having understood that, we'll move to our next slide. So the homologous families include, I'll request someone to raise their hand and they read for us these different names in the homo. Yes, Simix.
Alkanes, alkanes, alkynes, carboxylic acid, etc.
Okay, thank you. So we have alkanes. You can hear the name alkanes. And then we have alkenes, alkynes, alcohols, and then carboxylic acids. I'm going to request us that as I take them one more time, wherever you are, you don't need to unmute because you'll cause a lot of confusion. But wherever you are, just repeat these words after me. Alkanes, alkenes, alkynes, alcohols, and then carboxylic acids. So please take note of the pronunciation so that you don't confuse them. That's why I wanted you to repeat them wherever you are. Because it's important for you to know the pronunciation so that you know how to write them.
Yes, teacher.
Okay, so we'll look at the alkanes this afternoon.
So we are not seeing your screen.
Yeah, but it's there. It has alkanes. Is everyone not seeing it?
It is seen.
No,
Yeah,
we
it
can
is
see.
seen.
It's
No.
visible.
I can see.
Me too, I can see. Mirinda, I can see.
Teacher, I've seen it.
So we can see.
You can see, okay.
Not
So,
really.
Yes.
we can see. Okay, that's who can't see. Maybe you need to log out and then come back. Eh? It might be network issues. Okay, so who has an idea on what alkanes are or what an alkane is? Okay, Maria is saying they are saturated hydrocarbons. Good, though that is not the spelling for saturated. Eh? Saturated is SATURATED. Yes, Patricia?
I think alkanes are organic compounds that, which consist of a single bonded carbon, and the hydrogen atoms, they lack any functional groups, sort of.
Okay, that is very good. Thank you, Patricia. Please, I requested that the chat be used for academic ideas because I can't keep checking and people are talking things that are unrelated to what we are looking at. It causes a lot of disorganization. So please, let's focus. When we are here, we have 2 hours. Let's use them so that we learn something instead of using that chat for things that are not worth it. Eh? So let's really focus. And people who can't mind their tongue, please be polite. It's important in society to be polite. If someone needs to be added in the group, relax, be calm. We will look at those things as we end the lesson. But for now, let's focus our energies on learning. Very, very important. Eh? Because people spared their data to come here and learn, so we can't waste their time. Eh? So let's really focus. So, can someone define for us? Okay, let's hear from Tekino. Tekino, I don't know why you put up your hand and you don't mute your mic. You don't unmute, sorry. Nakanyike, please go ahead and tell us.
I think alkanes are substances consisting of hydrogen and carbon atoms, in which those atoms are arranged in a tree structure where the carbon bonds are single.
Okay, thank you. That is good. Kenneth?
I think alkanes are saturated hydrocarbons in which the valence of carbon is satisfied. And in alkanes, the carbon atoms are joined to other atoms by single bonds.
Okay, that is good. Hannah?
I think alkanes are the simplest family of hydrocarbons, which contain only carbon and hydrogen.
Okay, thank you. Aaron? Akram? Okay, so when we are looking at alkanes, we are basically focusing on carbon single bonds, or what we call saturated hydrogen carbons. Sorry, hydrocarbons. So, and when we are looking at hydrocarbons, of course, the same way you hear the word hydro and then carbons, that means it is containing hydrogen and what? And carbon as its elements. So, when we are looking at those alkanes, they are carbon atoms joined by single bonds, or what we call saturated hydrocarbons. And then, of course, members in this homologous series share a suffix, which is ANE. So every alkane will have an ending name as this. And this one here is derived from the name alkanes here. You realize that the last three letters,
the definition.
the definition of alkanes.
Yeah.
These are saturated hydrocarbons, or you can even say these are carbon atoms joined by a single bond. So you can say these are saturated hydrocarbons. And I said when you're looking at hydrocarbons, you're looking at hydrocarbons means they have carbon and hydrogen. For example, hydrocarbons. Saturated means they are joined by, the carbon atoms are joined by single bonds. For example, you'll have carbon joined to another carbon with a single bond. So that is why we call them saturated. And then hydrocarbon, I have said hydrocarbon is made up of two words, hydrogen and then carbon. So that means this is a compound made up of hydrogen and carbon only. So there is no other element there. It's just made up of carbon and then hydrogen only as its major compounds, as its major elements, sorry. So as I was saying, I don't know if the person who asked have been able to answer your question. I didn't take note of the name. So like I was saying, when you're looking at these alkanes, all alkanes end with a suffix ANE. And this ANE is derived from the name. That's why I wanted us to know how to pronounce those names, such that we get the alkanes and all alkanes end with ANE. So that means if I have an alkane that has one carbon atom, remember we said an element, a compound that has one carbon atom is written as what? As meth.
Meth.
Yes, very good. And then when we come to alkanes, because this is a prefix, the suffix there will be methane. You see that? So that means we have one carbon atom, and if it's an alkane, it takes on the name methane. So that is something that we are going to appreciate more as we go on. Okay, so let's proceed. So the definition is here, alkanes are compounds which have carbon atoms and hydrogen atoms with only single bonds. And this is here to show you what really happens. So these are compounds which have carbon and hydrogen atoms with only single bonds. And of course, we know that alkanes are saturated hydrocarbons. I've just explained that. So can we get someone to read for us the definition of what hydrocarbons are? Yes, Annabelle?
Hydrocarbons are compounds with only carbon and hydrogen atoms.
Okay, very good. So that is something you need to take note of. Hydrogen carbons are compounds with only carbon and hydrogen atoms. CM, your hand is up. You have something to ask? Okay, Patricia.
Okay, madam, what do you mean? Okay, back to the definition. What do you mean by a single bond?
Okay, we are going to look at that when you are looking at examples. Because when you're looking at hydrocarbons, we have hydrocarbons that have double bonds. We have those that have single bonds. We have those that have double bonds. We have those that have triple bonds. So all these, when you're talking about a single bond, we are looking at alkanes because they are made up of single bonds in their compounds. As you're going to see the examples on the next slide, you realize that most of them, actually all alkanes have single bonds. Also, you'll have an existence of something like this. So that is why we call them single bonds. We have to be specific that they are single bonds. And that is why we call them saturated hydrocarbons, because they exist as single bonds within their structures. Okay, so here we go. I want us to pay close attention here. We have number of carbon atoms. Our first element here is what? Is one carbon atom, and the prefix is meth. The suffix is N, and then the name there becomes methane. So because we have methane as one carbon atom, that means here we are going to have, if we have methane here, having one carbon atom, we know that if we have one carbon atom, for carbon to be complete, it must be bonded to 4 other elements because it has 4 bonds. Is that clear? So because it has 4 bonds, we need to account for those 4 bonds as we form the compounds. So that is why we have methane, and you have carbon bonded to a hydrogen, and carbon bonded to a hydrogen, and carbon bonded to a hydrogen, and carbon bonded to a hydrogen. So you realize that all the 4 bonds are being used for the hydrogen atoms because we know that methane contains only one carbon atom. So that is why you'll have C and then H4, because the C is 1 and the H is a what? A 4. And then it is qualified to become a what? A methane. Are we together on that? Okay.
Yes.
So I want us to try out. I want to go very slow here, and I want to go with us so that we understand every bit of this, because it will make the rest of the things very easy. So then we have the next one, which has 2 carbon atoms. What did we say was the prefix for the one that has 2 carbon atoms?
F.
F or E. Very good. And then the suffix here remains N. So that means the name becomes ethane. Yes, the name becomes ethane. So that means if the name has become ethane, we will have, that means we are going to have 2 carbon atoms, because we said ethene contains 2 what? 2 carbon atoms. But remember, we've said carbon must be bonded to 4 other what? Atoms. So 1 bond here has already been used. So how many bonds are we remaining with for carbon to have 4 bonds?
3.
3, very good. So that means the 3 are going to come here. We have 1, 2, 3, and then the 4th one. So that means these other bonds are going to be with hydrogen, because remember we say this is a hydrocarbon. And then here the same thing is going to be happening. So we'll have H here, and then H here. So you realize that here we'll have How many carbon atoms do we have here?
2.
2. So that means we have C2.
2.
And then how many hydrogen atoms do we have there?
6.
6.
6. So that means in the molecular formula of ethane, we have C2 and then H6. And then this is the structure formula where the atoms are spread out within the what? The structure. Are we together to that part as well?
Not
No.
really.
Okay, let me just use a whiteboard, because I think it will make it easier for me. Okay, so let's first go back to methane. We've said when we are looking at methane, we are looking at, we have one carbon atom, right? And we've said carbon can have only a maximum and a minimum of 4 bonds. So that means if we have one carbon atom, we are going to have a hydrogen here, a hydrogen here, a hydrogen there, and a hydrogen here. To make up for the 4 bonds, because remember we said alkanes are saturated hydrocarbons. That means they have single bonds. So you realize this is a single bond, this is a single bond, this is a single bond, and this is a single bond. So that means here we'll have one carbon, and we know in math we can't write 1x. So you just write what? X. So it's the same thing here. We write carbon and then the 4 hydrogens. And then we call this what? Methane. Is this one clear?
Yes.
Yes, madam.
Okay, good. So let's move to ethane. So we've said ethane has 2 carbon what? Atoms. Please, HP, stop writing on the screen. Thank you. So we have 2 carbon atoms. So we have this carbon atom and this carbon atom. So we have said carbon can only have a maximum and a minimum of how many bonds? 4 bonds. Is that clear? So if it has 4 bonds, we have already used one bond by bonding carbon to the other what? Carbon. So that means each of these carbons needs an extra of what? Of 3 bonds. So that means we'll have one bond here, one bond here, one bond here. But these bonds are between carbon to hydrogen, 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 carbon to hydrogen. So here, when I'm counting these bonds, I'm looking at, this is my first bond, my second bond, my third bond, my 4th bond. So you realize that this carbon atom here is bonded to 4 other what? Elements. Then even for this one here, I'll come and say this is my first bond, this is my second bond, my third bond, and then my 4th bond. So you realize that it is saturated. All those bonds are being what? Are being put to use. So you see that carbon is bonded to hydrogen, to hydrogen, to hydrogen, to hydrogen to give you the required number of bonds that you need for that component to become what? Ethane. And we said ethane has 2 carbon atoms. And of course, when we count the hydrogens are 1, 2, 3, 4, 5, and then what? 6. So that gives us C2H6. Are we together to that point?
Yes.
Yes. Yes.
Yes, ma'am.
Okay, thank you for that feedback. So then we move to the one that has 3 carbon atoms. The one that has 3 carbon atoms, we said is called?
Prop.
Prop. So when we add it to the suffix, what do we get?
Propane.
Propane. Very good. So propane, we've said this one has 3 carbon atoms. So how are we going to go about that? We'll come and write our carbon atoms, the 3 of them. So after writing them, you remember all of them are connected by a single what? By a single bond. So this first carbon here, how many more bonds does it need to have a complete bonding structure?
3.
3, very good. So that means we are going to create those 3 and bond them to what? To hydrogen. Is that clear?
Yeah.
Okay, good. So we have hydrogen.
Here. Is it like this?
Madam.
Is it my network or what? I'm not seeing anything. Please.
Yeah, me too.
Me three. Before.
I think it's the network.
Me 20.
Okay, guys, please be patient.
We are patient.
Okay. Missing it.
Okay, she's back.
Okay, sorry about that. I don't know what happened. Okay, I don't know what happened, but we can continue from where we had stopped. So we're still looking at propane. Sorry, propane.
Madam, we're not seeing anything on the board.
Guys, are you seeing anything?
Madam.
I think it's the madam's network, but okay, something is back.
I don't know what's happening to my network, but sorry about what is really happening. I'm about to understand. Okay, so we have the 3. So how many bonds does the middle carbon require to have a complete structure, as we said? 2, very good. Can we all see that it requires only 2 bonds?
Yeah.
Okay, very good. So we have the first bond here, the second one, so that means it will only require 2 more bonds. Very good. And then for the last carbon, how many hydrogen atoms will it require?
3.
3, very good. So that means we have 1 bond already, so we'll have 3 more. So that means in that case, we are going to have C3 and then H what? How many hydrogen atoms are there?
8.
H8, very good.
8.
So that is the molecular structure of propane. And then its structural formula is this. Are we all together up to that part?
Yes, madam.
Yes.
Okay, very good. And then for the fourth one, what did we say? How many carbon atoms does it have?
4.
And what is its prefix name?
But.
Bute. And then if it's an alkane, what name does it take on?
Butane.
Butane. Very good. Hey, you people are sharp. So we have 4 carbon atoms. And then we are yet to find the hydrogen atoms. So in this case, we have carbon, carbon, and then carbon. You realize that I am using single bonds only. So in that case,
Yeah.
how many hydrogens does this first carbon need?
3.
3, very good, because it already has 1 bond there already. So we'll have hydrogen here, and then hydrogen there. And then this next carbon, how many?
2.
2, very good. Because it already has 2 bonds. The next one? 2, very good. Because it already has 2 here. And then the last one? 3, very good. So we have hydrogen, and then hydrogen there. So that means how many hydrogens does butane have?
10.
10. Very good. So I hope we are noting down some of those things so that when we get to getting the general formula, people can tell me what we are using.
Yes, we are not.
Yeah, we.
Okay, beautiful. And then I'll task us to find the one for 5. Tell me how many carbon atoms they have. So
Madam,
quickly note that down.
Madam, I think 5 carbon atoms and 12 hydrogen atoms.
Okay, that is what? Pentane. You said pentane has 5, and then how many hydrogen?
6 carbons.
12.
Okay, is that what we've all got?
Yes.
Yes, madam.
And then for hexane?
Yes.
6 carbon, 14 hydrogen.
14
Okay.
hydrogen.
Good. And then for heptane?
7.
16 hydrogen and
15 hydrogen.
And how many?
16.
16.
16, very good. So as you go down these atoms, of course you can continue up to 10 in your free time. But what do you notice about the carbon atoms? What is happening to them?
They are just
They
increasing by
increase by
2.
1.
They're increasing by 1. Very good. And then for the hydrogens, how many?
By 2, madam.
Increasing by 2.
They're increasing by 2.
2.
So as you're moving from 1, as you're moving from 1, you realize that there is an increase by 2 to the next one. Is that clear?
Yes. Yes.
So that means the general formula for alkanes becomes CN H
Unmute.
2N plus. Sorry, let me just wrap that and I use this space. We get CN H2N plus, what do you think we add here? Plus what? Because we say they increased by what? By 2. So that means if we had methane, we had C4, and then when we went to ethane, we had C2H, H what? H6.
H6.
So that means to move from the first one, if here we had carbon 1, that means we had 2 times 1 plus what? Plus 2 to give us what? 4. Am I making sense?
Yes.
And then to go,
Yes.
when we went to ethane, we said C2H 2 times that 2 here plus 2 to give us 4 plus 2, which gives us what? 6. Are we together?
Yes.
So,
Yes.
the general
Yes,
formula
madam.
for alkanes is this: CnH2n plus 2. So that means the number of carbon atoms, if they are n, that means you come to the H, get 2 times the number of carbon atoms plus the 2 to give you the number of hydrogen atoms in an alkane. Are we all together up to that point?
Yes, madam.
Yes,
Okay, very
madam.
good. So you will keep trying out using that general formula and then you see what you really come up with in your free time.
Okay, madam.
Yeah. Okay, so let's move on to something else if there are no questions.
Madam,
Yes, please.
I missed the definition of hydrocarbons. Would you please pardon?
Anyone to tell us what they understood by the definition of a hydrocarbon?
Hydrocarbon are compounds with only carbon and hydrogen atoms.
Very good. So those are compounds with only carbon and hydrogen atoms. Have we answered your question?
Madam, let him pardon.
Okay, they are asking for your pardon.
Okay. Hydrocarbons are compounds with only carbon and hydrogen atoms.
So the answer is here. Thank you.
You're welcome.
Thank you.
You're welcome. Okay, so we move. So when these notes are posted on our group, kindly take out time to fill this table on your own. And for people who are noting down, I think that's a great deal for you to revise some of those things. Okay, so the general formula for alkanes, we've looked at that. And you can also get a way of deriving it yourself and still come up with the actual answer to that question.
Madam, I've tried and
Okay, that's good. Thank you. Then this is our research work. Please write down this question. I would love to see our videos in our next lesson on the model that we'll have come up with. So you're going to go and find out how does the structure look like and how can I get available resources in my environment to come up with that model. So please write down that question. Develop a model of alkanes using available resources in your environment.
Madam, pardon the question.
The question is here on the screen. You can copy it. Develop a model of alkanes using available resources in your environment. Please, when you're through, you can let me know when you're through copying it.
Madam.
We are done.
Madam.
Yes, please.
Madam, we are done here.
Not
Madam,
all
please
of us.
elaborate on that.
Madam, we are done.
Elaborate on what the question means.
No.
But you're supposed to go and find out, make research on how you can develop a model. We've looked at what alkanes are. Choose maybe one alkane that you can work with and you use the available resources and come up with its structure because we've looked at the structure formulae. So you can get materials that can help you come up with a specific structure. Maybe you can choose a methane, you can choose ethane, propane, butane, depending on what you feel like, but use the available resources to come up with that model on how that structure looks like. That is what basically the question is about. Is that more clear?
Yes, madam.
Yes, madam.
Yes, madam.
Yes,
Okay,
thank you.
All right. So, do I have a co-host? Because okay, CM, I think you will end the recording because my phone is about to shut down and we don't have electricity this side. So I don't know how we'll do that. So, but wherever we'll have stopped, you'll kindly help me end the recording so that at least people can have the recording after the lesson.
It's okay.
Yeah, but for now we can keep moving. But if I get lost in any way, you just do that. Carly, so the physical properties, what are some of the physical properties of alkanes?
They have single bonds in their structure.
Wow, very good. They have single bonds in their structure. Any other? Okay, so when you're looking, they are
so reactive.
Okay, when you're talking about their reactiveness, we really look at that in what? In chemical properties. But when you're looking at physical properties, we are looking at how they respond to physical terms. Maybe melting point, boiling point. Are they soluble? Are they less dense? Things like that. Yes, Rebecca.
They are made up of carbon and hydrogen as its element.
Okay, they are made up of carbon and hydrogen. Thank you. That is good. So then we also have the melting and boiling points. And we know that when we are looking at these hydrocarbons, melting and boiling point increases with increase in the number of carbon atoms. So it's the same thing that if you have little water and you're boiling it, it will boil faster. But if the water increases, that means you will need to, it will take more time, it will take more heat. So it's the same thing here. When you have many carbon atoms, that means also the melting and boiling point also does what? Increases. Okay, so we have a graph here that is showing the melting point and boiling point. It may not be so clear, but I just want us to focus our energies. This side here is showing the melting and boiling point, while down here it's showing the number of carbon atoms. You can see carbon atom 1, carbon atom 2, carbon atom 3, 4, 5, up to 16. The red line is showing the boiling point, while the blue line is showing the melting point. So you can see at least something is happening. What do you think is happening to these melting points as the carbon atoms increase? Anyone with an idea? You can post in the chat or you can raise your hand. Yes, Prime.
Madam, I think that when the carbon atoms increase, the melting point also increases.
Okay, that is good. And also, the same thing is happening with the boiling point. The boiling point is the red line. So you can see there is a drastic increase in the what? In the boiling point. But there is something to note about the melting point. When you look at this melting point here, when you look at the carbon atom 1, 2, 3, and 4, they are always in gaseous state. So that is why you realize that their melting point is a bit, there is an increase, but it is very, very small. And then when it reaches 4, then it goes on increasing like that, but not at a sharp increase. So when you're looking at these, you realize that from carbon atom 1 to carbon atom 4, we have the gases. That means methane, ethane, propane, and butane are what? Are in gaseous state as alkanes. And then when you look at pentane up to around 17 of those carbon atoms, those ones are liquids and the rest become solids. So it is something to really take note of as you go about those. So there is this question here. How do melting and boiling points of alkanes vary with the number of carbon atoms? Of course, we've said that melting point and boiling point increase with increase in the number of carbon atoms. And therefore, there is an increase in molecular mass since the van der Waals forces of attraction also what? Increase. So the van der Waals forces of attraction, these ones are basically the forces that hold nonmetals together. So these forces here become increase with the increase in the number of carbon atoms. So the higher the carbon atoms, the higher the molecular mass. That means the molecular mass increases, the mass of those compounds increases. And if it increases, therefore the forces also do what? Increase. Therefore the melting and boiling point will also increase because of that. Are we together at that point?
No.
No.
Madam. No.
Yes.
Okay. So I'll repeat, let's all listen. Eh? When you look at this diagram here, we've said melting and boiling points are increasing, but you realize that here we have carbon atom 1, we have carbon atom 1, carbon atom 2, 3, 4, 5, 6, up to 16. So you realize that the number of carbon atoms is increasing. Remember, we said that carbon atom 1 is called methane. Carbon atom 2 is called ethane. Carbon atom 3 is called propane. As you go on and forth up to 16. So there is an increase in melting point and an increase in what? In boiling point. But remember, as we increase, methane has 1 carbon atom, ethane has 2 carbon atoms, propane has 3 carbon atoms, 4 carbon atoms, up to 16 carbon atoms. That means as the number of carbon atoms increases, also the hydrogen atoms are what? Are increasing. Are we together at that point?
Yes.
So if those two are increasing, that means the mass of that compound is also what? Increasing. So remember, as the mass increases, we've said the van der Waals forces are holding those atoms together. So that means the van der Waals forces also increase. Please, can we mute?
People,
Members, mute.
guys, get this.
Okay, so I was still saying, as the mass increases, the forces holding those molecules together also do what? Increase. And if they increase, that means they're going to require a lot of heat to overcome those forces. That is what causes the melting point and then the boiling point. And then I gave an example that, for example, if you have very little water, maybe half a cup boiling, and then I have 5 liters boiling, which one will boil faster?
Half a cup.
Half a cup, very good, because it's little. But when you look at the carbon atom 1, it has a lower boiling point and lower melting point compared to 16 because of the fact that for it, it has less carbon atoms, therefore it has weak van der Waals forces, which are few. But when you look at 16, 16 has many carbon atoms, many hydrogen atoms. That means at that point, it has many forces of attraction within its what? Its compound. And therefore the melting and boiling point will also increase because the mass has what? Has increased. Is that clear?
Yes.
Making
Okay.
noise.
Thank you. So please, when the recording is posted, you can go back and listen to it so that the points you didn't understand, you can review them. And in the next lesson, if you have questions, we can answer them before we move on.
Okay, madam.
Okay, so then, of course, we mentioned some physical properties. I want us to quickly write through them. Alkanes are colorless and odorless. That means they have the same color like water, and then they are odorless. So they have no smell. And then alkanes, I explained this, that when you have from carbon atom 1, from methane to butane, you have carbon atoms which are gaseous. They're in gas state. And then 5 to 17, they are liquids. And then 18 and above, they are what? They are solids. So you need to know those different states in which those alkanes exist. From carbon 1 to 14, they are, sorry, to 4, they are gases. From 5 to 17, they are liquids. And above 18, they are in solid state. And then alkanes are insoluble in water, but soluble in organic solvents, such as benzene. And we have understood that alkanes are organic compounds. That means they dissolve in fellow organic compounds and insoluble in inorganic compounds like water. So that means you cannot find alkanes dissolving in water, but they will dissolve in organic solvents like benzene. And then the density increases with increase in molar mass, but branching reduces this trend. So as the density increases, the molecular mass increases with increase in density. So that means if the mass increases, that means the density also does what? Increases. For example, you can find that something that is lighter, it will float on water, while something that is more dense will sink in what? In water. So that is the same thing here. When the mass of the alkane is big, therefore the density will also be what? Big. But if the molecular mass is small, therefore the density will also be small. So those are some of the physical properties that you really need to take note of. And maybe this diagram is showing the different melting points and boiling points of those.
Yes. And I'm first to show the physical properties.
Okay. Yes, Hannah?
Teacher, may you please just show the physical properties one more time? Thank
But
you.
they're the ones on the screen, aren't you seeing that? Okay, when we are through, you can let me know so that we move to the next slide. You can even take a screenshot to save time, and then you can copy
I'm
them
finished.
later. Okay. Thank you.
Not yet.
Because even the time isn't on our side.
The network.
Okay, so I think we'll need to have to begin from there because I don't want us to look at something else that will require more explanation and I go off instantly. So I think we'll have to stop there, and I hope we've learned something today. And please kindly go back and review those things so that in the next lesson when we come, we can know where to start from. Is that clear?
Yes.
Yes.
Yes, please, CM.
Okay,
Madam.
Guys, can I please be able to hear? Can you mute your microphones?
Madam, some quiz.
Okay, the quiz will be posted along.
Madam, aren't you having the quiz?
No.
Okay, guys, talking about the group. Some of us aren't in the group. How do we get in?
You can like ask for the link